Swayam Prabha. Digital India. Educated India.
Hi friends, now we will discuss on the topic gasification of coal. We will cover this topic in two classes, and in the first class we will discuss on, and the contents of the first class are definition and basic chemistry of gasification, gasification reaction schemes and steps, then syngas production and efficiency and factors influencing gasification, advantages of gasification, typical process flow sheet and utilization schemes for gasification products, gasifier types, advanced gasification and some coal based gasifiers. Now, we will see what is gasification. As you have discussed in the introductory module in the previous class also, that gasification is the process which uses controlled amount of oxygen and converts carbonaceous materials into carbon monoxide and hydrogen rich gas, that is called syngas. So, in this process sometimes steam is used. For coal steam is used, but for very biomass steam requirement may be very less, because coal is having more carbon. So, steam is required for this process with the coal, and this syngas can be used for various applications, including the liquid fuel production through the Fischer-Tropsch synthesis. And if air is used in this process in place of oxygen, then the syngas contains more amount of nitrogen, and that is called a producer gas. As you have already discussed in the previous class, that for oxygen and coal ratio for gasification is within 0.68 to 2.5, and in this case these are the products. But we increase the R, then what will happen? We will be getting more CO2, and we reduce the R value, we will be get more CO and H2. So, this is the basics of the gasification process. Now, we will see the chemistry, the reactions, what happens in, what type of reactions takes place in case of gasification process. So, we have here feedstocks coal, we have oxygen and we have steam. Now, these schemes shows us elemental reactions. The coal is having carbon, it is having hydrogen, it is oxygen, sulfur, nitrogen, etc., but we are considering the major components of the coal, that is carbon we are considering in this case. So, the first reaction, carbon plus half O2, controlled amount of oxygen. So, CO, we are terming it as gasification with oxygen. So, heating value is minus 0.5 kilojoule per mole. Combustion with oxygen can take place, C plus O2 then CO2. So, this is again exothermic reaction. So, these two reactions are exothermic reactions which provides us heat which are required for other reactions, say gasification with carbon dioxide, C plus CO2. So, that is 2 CO, this is endothermic reaction, and C plus H2O, that will also give us CO plus H2, again endothermic reaction, and gasification with hydrogen, that is exothermic reactions, but this heat is very less. So, C plus 2H2 CH4, and at the same time under the same condition some water gas shift reaction takes place, CO plus H2 reacts to form H2 plus CO2, and some methanation also take place, that is CO plus 3H2, that is H4 plus H2O. These two reactions are also exothermic in nature. So, overall if we see it is having both exothermic and endothermic reactions. So, initially we need to provide oxygen, the reactions that energy will be released, that will be used for these reactions. Now, what are the composition of the syngas? and producer gas. Here it is provided hydrogen, CO, CO2, CH4, these are the ranges for syngas. Hydrogen is 20 to 30% and producer gas 13 to 19%, CO for syngas 40 to 60% and producer gas 18 to 22%, CO2 5 to 15% for syngas and 9 to 12% for producer gas, and CH4 0 to 5% for syngas and 1 to 5% for producer gas. Heavier hydrocarbon may be present in this, and nitrogen in case of syngas 0.5 to 4% and here 45 to 55%. Water vapor 8 to 10% for syngas and 4% for producer gas. Now, the heating value, which is most important in our case. So, for syngas it is 9.3 to 14.9 megajoule per meter cube, where it is 4.5 to 6 megajoule per meter cube in case of producer gas. Now, we will see the mechanism of the gasification, how the gasification takes place, what is the mechanism. If we apply heat and controlled amount of oxygen, then what type of changes are going to take place. So, if we have feedstock, then initially you are heating. So, then will be char and volatiles formation, volatiles will be going off. So, that volatiles will be further gasified, char will be further gasified and ultimately it will give us syngas. So, how this gasification taking place? The representation of this process is your CnHm plus half NO2, that is half MH2 plus NCO, and char gasification means it will be having carbon, hydrogen, oxygen. We are ignoring other impurities in this case. So, then it will give, this is the empirical formula, this is the formula. So, which is explaining that this will be hydrogen production and this will be the CO production from this char. Now, you see what is happening, we will be trying to understand more inside the mechanism, on the mechanism. Okay. So, this is the gasifier, we are putting feed here and we are putting oxygen or air and steam here. So, gradually feed is getting down and gas goes up. So, here is a grate, this grate is there. So, solids are falling and it is getting in contact with hot gases and different types of processes are going on, changes are going on, and ultimately ash is formed and ash is stored on this grate or something is passed through the opening of this grate and here ash collection takes place. And what are the different types of changes on the coal? When it is getting entry here, it is coming in contact with gradually increasing temperature. Why? Because oxygen is provided here. So, maximum oxygen is available in this zone. As we go up, oxygen concentration reduces. So, once oxygen concentration reduces, then there will be less combustion, the temperature will also fall. So, temperature is highest in this case, oxidation zone, high temperature, and then the temperature is gradually reducing. So, oxidation up to this say it is stopped, then reduction will take place. If oxygen is not available, then heat is available, endothermic reaction will go on and then reduction will take place. And here pyrolysis will take place, high temperature is there, oxygen is not there. So, pyrolysis take place and here we will be having drying, only the moisture will goes up, volatiles will goes up and then these volatiles will be gasified and char will be gasified at this temperature, and here char gasification, volatiles gasification will take place. So, this is a different types of phenomena which is going on inside the gasifier, that is drying, volatilizations and pyrolysis and then reductions, then oxidation and ash cooling. So, unlike incineration, in case of gasification what is happening, the volatiles are not completely combusted, because the volatiles are produced here say, so it is going off, it is getting less chance to be converted more. So, for fixed bed type of reactor, fixed bed type of gasifier, the flue gas the syngas which is coming out, that will not be of that pure, it will be having some volatiles. So, tars will be available with this. So, in 2006 Valero they have presented this phenomenon nicely, considering the presence of ash as well as sulfur, nitrogen, etc. They have given the molecular presentation of the coal, that is CHHOONNSSZ plus AO2, and this is converted to CO2, CO, H2O, H2S, N2 and Z. Z is our ash. So, this is the reactions they have proposed, and they have shown the mass balance and how to calculate A, how to calculate H, O, N, S, Z, etc. So, this is one reaction, that is your reactions with oxygen. Then reactions with carbon dioxide, similar presentation they have provided, and then reactions with steam gasification. These are the proposed reactions, and then reactions with hydrogen. So, these are the proposed reactions. So, if we use this scheme of reactions, we can predict the compositions completely, what is the H2S compositions, what is nitrogen compositions, what is CO, what is CO2, etc. And important gas phase reactions which takes place here, that is your H2S plus CO2, COS plus H2O is formed. Now, we will discuss about the syngas production and efficiency. What is the syngas production? What will be the fuel gas productions or syngas production? That can be calculated on the basis of nitrogen balance, and the expression is fuel gas production normal meter cube per kg is equal to air flow rate in normal meter cube per second into 0.79 divided by 1 minus CO plus CO2 plus H2 plus CH4 plus C2H2 by 100 into feeding rate. Now, we are assuming that the syngas is containing these gases only, it is not having any sulfur or any nitrogen. In that case, this formula we are using. So, what is this? 1 minus this by this, that is equal to 100, that is equal to 100 minus CO minus CO2 minus H2 minus CH4 minus C2H2 divided by 100. That means, this is nothing but the nitrogen available in this, as we are providing controlled amount of oxygen. So, we are assumed that all oxygen is consumed. So, remaining will be nitrogen. So, 100 minus this is equal to nitrogen. So, this is the percentage of nitrogen. So, percentage of nitrogen into, we are getting feeding rate, and here flue gas production is given. So, that will be the nitrogen available in the fuel gas, and this is the nitrogen available in the feedstock. So, nitrogen balance is there, we are assuming that 79% is nitrogen. So, that way we are getting this relationship. Now, we can determine the yield of hydrogen and carbon monoxide as hydrogen yield is equal to hydrogen atoms in the syngas divided by hydrogen atoms injected in the feed, and CO yield, that is carbon atoms in the formed CO by carbon atoms injected. Now, we will see the efficiency. So, efficiency is related with heat. So, obviously, LHV of cold gas, that is kilojoule per normal meter cube, into fuel gas production, that is normal meter cube per kg, divided by LHV of the coal treated plus allothermal power by coal flow rates. That means, for unit amount of coal, how much energy associated with this process are required. For example, say for size reductions, for grinding is required, so that energy is needed. So, that is also considered here. So, allothermal energy divided by coal coal flow rate. So, this is the expressions of the efficiency of the syngas production process. The conversion efficiency of thermal power plant is between 30% and 40% for a single cycle steam power plant, as we have discussed in our previous class, and this can be increased up to 60% for a combined cycle gas turbine power plant. also we have seen that this is the thermodynamic limit, thermodynamically 63% efficiency can be increased. Now, we will see the factors which influence the gasification process, the type of feed injection, what type of feed we are injecting. So, coal may be at the top feed or may be side feed. So, if we change the feeding coal feed positions, then the efficiency will be changed, because it will be getting different time to be in contact with the hot gas. And the gasification agent, air or oxygen may be used. As you have discussed that if we use air, more nitrogen will be available in the syngas, resulting producer gas, and the energy value will also be less. The type of heating, what type of we are heating? It can be done either by partial combustion of the coal in the gasifier directly, or from an external source, also indirect heated also possible. So, both these cases efficiency will change. And the temperature range, at what temperature we are using in the gasification reactor, that will also influence the performance, and the pressure range under which the gasifiers are operated. So, these are different parameters which influence the performance of the gasification process. So, different types of gasifiers have been tested and developed and used for the coal gasification, and different efficiency have been achieved also. Now, what are the advantage of this process? It reduces carbon dioxide emission, as complete combustion is not taking place. So, carbon dioxide emission is reduced with respect to combustion method. Compact equipment requirements with a relatively small footprint, the equipments are very compact and footprint requirement is less. And then accurate combustion control, as we have already discussed it, that we are controlled amount of oxygen we are providing, and high thermal efficiency, we get more efficiency in this method than the combustion process. Now, we will say the how we will use this, the flow sheet and utilization schemes of gasification products. So, we have coal here, then we are sending it to gasifier with steam and oxygen, then we will get syngas. So, syngas gas has to be cleaned up first, the first stage of cleaning. So, we are removing the particulates here, and then second stage of cleaning we are removing the sulfur here, then it is coming as a pure syngas, and syngas there will be some conditioning and then utilization. So, that is we can go for processing, that is liquid fuels and chemical synthesis. We can separate the hydrogen from the syngas, and hydrogen vehicle fuel it can be used. Hydrogen can be used in fuel cells for electric power, or syngas can be sent to gas turbine. So, it will be electrical power production, and then gas turbine exhaust can further be heated by using some additional fuel, and then it can be sent to waste heat boiler, and steam can be produced and can be electricity generated from the steam turbine, and this condensed from the boiler, the steam can be passed here for the gasification, and at the bottom what we will get that ash, that will be slag or metal recovery. So, these are the different processes or schemes which can be used for the utilization of products of the gasification process. So, apart from electricity generation, we can have number of opportunities to utilize the products which is generated through the gasification. So, we will be having more opportunity to make the process more economic, and polygeneration option is utilized and recommended for application. Now, we will say major types of gasifiers for coal gasification. So, on the basis of the feed, inlet, gas collection and the operating conditions, different types of gasifiers are reported. Out of these, moving bed, fluidized bed and entrained bed are major three important gasifiers which have been used widely for the gasification of coal and other carbonaceous feedstocks. In the moving bed, coal is fed at the top and the particle size is higher, say 5 to 50 millimeter particle size. So, it falls from the top and from the bottom oxygen, air and steam is sent. So, reaction takes place as I have discussed in the previous slide also. So, gradually it falls and ash is getting out from the bottom. So, if we see the temperature profile across the height of the gasifier, then this will be the nature. So, if we increase the height from the bottom, so gradually temperature will increase and will at its maximum, then again it is decreased, because oxidation is taking place at the middle of this. So, that is having the maximum temperature, it is around 1800 degree centigrade temperature it can give. But if we see the fluidized bed, coal is put here. So, here steam, oxygen or air, then there will be some fluidizations of the particles, we will be taking smaller particles here and then that will be in fluidized form. And due to this reason, what will be the temperature profile across its height? This is, so it will gradually increase, remain constant most of the part and then it is decreased. Up to this part it will be constant and it is decreased, this part will temperature will drastically decrease. And another is entrained flow reactor, here we send coal and then steam, oxygen or air, very finer particles are used, the particle size is much smaller than this fluidized bed, and both all these coal, steam and or air or oxygen flows in the same direction. So, it gets less residence time and ash collected here and gas goes from this at the bottom. Due to this feature, that if we see the temperature distribution along the height of it, it is almost constant and maximum on this, but not maximum, here we will get maximum temperature, because oxidation is single, it is certain zone, but here uniformly distributed the phenomena. So, these are the temperature profile across the height of the gasifier for different types of gasifiers, and this we have already come to know that here the less time is less residence time and smallest particle size with respect to these three gasifiers. But these fluidized bed gasifiers have some advantage, that it can in situ capture of sulfur. So, that is why transport reactor gasifier has been developed by KBR. So, in this case we have the intermediate properties, both the fluidized bed and entrained bed properties are available here. How? We are putting here fuel, then adsorbent, we are putting some adsorbent also, that is to capture the sulfur, and then oxygen or air and steam, all are here in coming into this reactor. Then it is going up this riser section, very small time it is getting for contact, then it is coming to this. So, it is falling again and the gas is coming here, particulate separation, it is coming back. So, that way here we are getting the benefits of fluidized bed, we are getting the benefits of entrained bed. So, both features are available in transport reactor. So, in this case we do not need to use very finer particles than that of entrained bed. Now, we will see the comparison of this type of gasifiers. So, fixed bed, fluidized bed, you see these are the technology licensors, BGL, Lurgi, Dryas, that is the fixed bed, and KTW, IDGCC and KRW and Mitsui Babcock. So, these are the technology licensors, and typical process conditions for these are the combustion temperature is 1300 degree centigrade and slurry feed if it is, and if it is a dry feed then 1500 to 1800 degree centigrade, but gas outlet temperature is less, 400 to 500 degree centigrade, and pressure is this much and particle size already discussed. Cool gas efficiency is high, but fluidized bed the combustion temperature is more, but lesser than this, and gas outlet temperature is more than this one, and pressure requirement is also this one, and residence time is less, particle size is less, coal gas efficiency is medium. If we go for entrained bed gasifier, then 1500 degree centigrade reaction temperature, gas outlet temperature is also higher than other two types of gasifiers. Then pressure requirement this and retention time is also lesser, and these are the particle size less than 200 mS, very fine particles are required. Now, we see the transport reactor, it is in between. So, temperature is 900 to 1050 degree centigrade, gas outlet temperature 590 to 980, and residence time 1 to 10 second, just like your intent bed, and size is less than 50 microns. So, we do not need to get 200 means 70 microns, and it is having 50 micron size. Now, we will see the advanced process in gasifications. The plasma gasification is one of the advancement in the gasification process. In this case, we use high voltage across the two electrode. So, in that case the electrons are emitted, then electron accelerates free electrons, electrodes accelerates free electrons, and free electrons helps to oxidize or ionize the ions, adjacent ions and molecules, and then number of electrons are produced which forms a avalanche, that is called streamer. So, that is called the plasma. In this case, torch power levels from 100 kilowatt to 200 megawatt and produce energy densities up to 100 megawatt per meter cube. So, in these cases different free radicals are formed which converts the different types of components present in the coal to its oxidized form. So, C is converted to CO2, H is converted to H2O, N is converted to NO2, S is SO2, like this. But typically it has been shown that the CO and H2 gas remains in higher concentration. These are some coal based gasifiers around the world. So, China, Germany, Italy, Netherlands and South Africa, Spain and USA. In these countries different gasifiers are, the plants are there where the gasification process is in practice, and different types of products they are producing. There somewhere we are getting say FT fluids and then electricity, some are ammonia, some are town gas and electricity, some are ammonia, again some syngas, some are methanol, okay. And then we are getting some are FT fluids and methanol and chemicals and SNG and then electricity. So, some diesel and electricity is also produced by some plants, and different types of cleaning options are also used, rectisol, sulfinol, MDA, etc. So, I will discuss this in next class. Okay. So, thank you very much for your patience.